So example 2, we've got a police cruiser. This one's my favorite question. Cops and robbers approaching a right-angled intersection from the north, and it's chasing a speeding car that has turned the corner and is now moving straight east. So when I draw this picture, we've got a car approaching an intersection, and it says the car is approaching from the north. So that means it's traveling south. We're going to call that the police car. That's going to be my Y value. And then we've got the crook, I like to call it the robber, has turned the corner and is heading due east. So it's heading to the right, and that's going to be my X value. And it says when the cruiser is 0.6 miles north of the intersection, so that's going to be one of our pieces of information when Y is at 0.6 miles, then the car is 0.8 miles to the east. So my robber is 0.8 miles to the east. The police determine with a radar that the distance between them and the car. So let's say cruiser is here, car is here. They're talking about this straight line distance between them. And notice it doesn't tell you what the distance is. It just says that the distance is increasing at 20 miles per hour. So they've given you a rate. I'm going to call it change in S with respect to time is 20 miles per hour. So I'm going to label this side S. Then it says if the cruiser is moving at 60 miles an hour, that was this Y value. Now, something important here is that this cruiser is traveling south. It's going down. Velocity can be negative. Speed cannot, but velocity can. So we're looking at this as change in Y with respect to time is negative 60 miles per hour. That's going to be really important that that's a negative value. They want to know what is the speed of the racing car. Okay, so we don't know. I'm not even going to call it X because that would get confusing. So the change in speed of our car is question mark. All right, so this is what we're trying to find. Here's all the information that we have. We need to set up an equation that relates X, Y, and S. I can see I've got all of these different values. What I'm missing here is a value for just plain old S. However, I do know this one was 0.6, this one was 0.8, not 0.81. And this is a right triangle, so I can just do Pythagorean theorem, 0.6 squared plus 0.8 squared equals S squared. So when I do this, I get 0.36 plus 0.64. I get 1 equals S squared. So we get that S has to be 1. Now, using that information, relating X, Y, and S, I already used the equation. So my equation I'm going to use is X squared plus Y squared equals S squared. Those are all static values. I don't have any rates in this question, and I can see I've got 2 rates and I need to find the third. So I have to introduce the rates by doing the derivatives. So the derivative of X squared with respect to time is 2X dx dt. And the derivative of Y squared with respect to time is 2Y dy dt. And the derivative of S squared is 2S ds dt. Now I've got all of the information I need. I know that X was 0.8. dx dt is what I'm trying to find. I know that Y was 0.6 and dy dt was negative 60. I know that S was 1 and ds dt was 20 miles an hour. So go ahead and plug all of this into the calculator and solve for dx dt. I'll give you a second to do that, or just pause the video and plug that in. And so we end up getting that dx dt equals 70 miles per hour.